Hello and welcome back. In this video we're going to introduce you to Chapter 15, which is the study of thermodynamics. So thermodynamics is the study of processes in which energy is transferred via work, remember work got the symbol W, and heat. Heat gets the symbol Q. So thermodynamics only concerns itself with energy transfers due to either work or heat. Period. Recall from Chapter 13 that U is the symbol that we use to keep track of the internal energy for a system. So the 0th law of thermodynamics is one that we have seen before, and we're going to introduce you now to the other two laws of thermodynamics. There are 3 laws total, and the 0th law I think we got introduced to in Chapter 13. It says that if system A is in thermal equilibrium, remember this is standing, TE is standing for thermal equilibrium. I'll write it out here so you can recall that. Is in thermal equilibrium with system B, and that means they're at the same temperature. And system B is in thermal equilibrium with system C. Then system A is in thermal equilibrium with system C. So if A is equal to B, B is equal to C, then A is equal to C. The first law of thermodynamics is a conservation of energy law, and it says that any change in the internal energy for the system is going to be equal to the heat added to the system minus the work done by the system. Notice that we have to be very, very careful in the way we define Q and W, because Q could either be heat added or heat removed. Okay, the first law, as stated here, this Q is the heat added. If the heat is instead removed, then we would plug in a negative value for the Q. So if we're told 50 joules of heat is removed, then we'd put in minus 50 joules for this value of Q. W could also be the work done by the system or the work done on the system. So the system is generally a collection of molecules that we're looking at studying. It's mainly going to be gas molecules for our purposes. And so when work is done on the system, then the system gains energy. When work is done by the system, then the system loses energy. So you can see that we have the first law defined as Q minus W. So W here is the work done by the system. So if we're told 50 joules of work is done by the system, then we put in 50 joules here, and you see that we'd be subtracting that. If instead work is done on the system, then W is negative. So if we're told that 50 joules of work is done on the system, then we would plug in minus 50 here and this negative sign, and the negative sign we plug in for the 50 joules would cancel each other to make a positive, and that would be effectively increasing the internal energy of the system. So this is just an energy conservation law. It says any change in the internal energy is going to be due to heat added to the system and work done by the system. So really get down what I have here as far as Q and W and their definitions. Okay, that is the one place where people can get confused. And if you can get it straight in your head to begin with, then you'll proceed through problems, and that'll just reinforce the definitions for you. The second law of thermodynamics has to do with the direction that we see natural processes take. For example, we see heat only flowing from hot objects to cooler objects, not the other way around. We don't see heat flowing from a cold object to a hot object and heating that hot object up further and cooling the cool object down further. And there wouldn't be a violation of conservation of energy if that happened. It would be fine as long as the energy before and the energy after is the same. So we need another law to dictate the direction that we see processes go. And it turns out that for natural processes, heat flowing only from hot to cold, for example, the change in a quantity we called entropy, which gets the symbol S, is always greater than or equal to 0. So the change in entropy is always greater than or equal to 0. This is always true. So the special quantity called entropy is always 0 or positive for any natural process. So S actually is defined as, entropy is defined as the integral, and that's the area under the curve, of dq divided by the temperature T. So this is obviously something we're not going to be using in this class. I just wanted you to see that that's what it is. And we won't be doing a whole lot with this. We'll be doing a little bit. But notice that if using differentials, we can write what entropy is exactly. But for our purposes where we don't deal with differentials, we can write entropy as the change in heat divided by the temperature. So this will be the form that we will use as we proceed forward. So this is just to give you an overview of the laws of thermodynamics, introducing thermodynamics to you. And in the next video, we'll delve a little bit deeper considering the first and the second law. So to begin with, we'll look at the first law in the next video. We'll see you then. Thank you.